guys, this is the next lecture of trigonometric identities. I think this is our third part. Alright, we'll be solving a few more sums. Nothing new you need to know other than the basic formulae and the identities. Alright, so let's get right into it. This is our first sum. All the sums again are proof that type. This was asked in ICSE 2015 and 2003, so it seems like an important type. It's very easy. Okay, so how will I approach this sum? See, when I see on my RHS, I need cos and sine. LHS is a mixture of cos, sine, tan, cot. So what I'll do is I'll write tan and cot in terms of sine and cos. So this is what it will look like. I'll take my LHS. I'll write cos A upon 1 minus sine A by cos A plus sine A upon 1 minus cos A by sine A. Please don't make a mistake here. Cot is cos by sine, tan is sine by cos. Now what I'll do is I'll take LCM in the denominator side. Get cos A minus sin A upon cos A plus sin A. Let's make a bigger dash so you know. Sin A minus cos A upon sin A. This is what I get. Alright. Now this is a certain thing upon a fraction, so it gets reciprocal. So when it gets reciprocal, I will get cos square A upon cos A minus sin A plus numerator into reciprocal of denominator. So sine square A upon sin A minus cos A. Now we need cos A plus sin A on the RHS. How will I do this? Okay, guys, don't over here, don't take the long cut and multiply these and try to find the LCM. Instead, focus on just taking minus common from here. If you change this sign into a minus, this will become a plus. Am I right? And sign will become a minus. Basically, I've taken out minus common. So when I take out minus common, this will look something like this. Cos square A upon cos A minus sin A cos square A upon cos A minus sin A minus sin square A upon cos A minus sin A. This is how I made the denominators equal. How did I do that? I took minus common, take minus 1 common. So this becomes cos square A minus sin square A upon cos A minus sin A. Alright. Now over here we'll use nothing but A square minus B square formula. So I'll use A minus B into A plus B upon the denominator. Now if you notice cos A minus sin A is there numerator and denominator. So we can have that cancelled. And once we have it cancelled, we will be left with cos A plus sin A. Very simple sum. This is your RHS. For those who didn't understand, A square minus B square, and this is A minus B into A plus B. Cancel, cancel. We are left with our RHS. Next sum. Alright, in this sum, I picked up this sum because multiple formulae are used. We use the a cube plus b cube, a cube minus b cube formula, which is very important to remember because it helps us a lot in this sum. Let's show you how. Obviously, start at the more complicated side, LHS. Here we'll apply a cube minus b cube. Why? Because this is like a cube, this is like b cube. On this side, it's like a cube, this is like b cube. How will I write it? A cube plus b cube is a plus b into a square minus ab plus b square. is your formula. Don't do anything. Do not take LCM in the denominator, please. Just leave the denominator as it is. Now here we'll say A minus B, right, into A square plus AB plus B square. As I said, leave denominator as it is. Now a lot will get cancelled. A lot will get cancelled. Firstly, this will cancel with this and this will get cancelled. Next, notice cos square A plus sin square A. Cos square A plus sin square A. This becomes nothing but 1 because of the identity. What identity? Cos square theta plus sin square theta is equal to 1. I use that identity. So what are we left with? What are we left with? I will show you what we are left with. We are left with nothing but 1 minus cos A sin A plus 1 plus cos A sin A. And this gives us 2, which is equal to your RHS. Hence proved. Very simple sum. All you needed to do was know your formula. Our next sum, they've just tried to trick us very slyly over here. All you need to do is, when you take your LHS, write 1 upon cos A as sec A. 1 upon cos A, write it as sec A. Alright, that's all you need to do. Rest all will be handled. Taking LHS, tan A plus sec A whole square plus tan A minus sec A whole square. Alright. Once we expand this using what formula? We'll be using these two formulas. We'll be using the expansion A plus B whole square, and we'll be using this expansion A minus B whole square. So A plus B whole square is nothing but A square plus B square plus 2AB plus A square plus B square minus 2AB. Now if you notice, plus 2 tan A sec A and minus 2 tan A sec A, they cancel each other out. So we will be left with 2 common tan square A plus sec square A. Because 1, 2, 2 tans, 1, 2, 2 sec, this and this go. Okay, now it's our time to take the RHS. Leave the LHS at 2 into common tan square plus sec square A. Take RHS now. RHS is 1 plus sin square A upon 1 minus sin square is nothing but cos square A. Now what you do, inside the brackets only, split the numerator, as the denominator will stay the same. Now guys, if you notice this is nothing but 2 into sec square A plus tan square A, and this is nothing but your LHS. Hence proved. Hence proved. This is nothing but cos square A. Okay. So this was how you solve the third sum. Very simple solution. Next, we have to prove this is left hand side is equal to right hand side. Here also very simple solution. All you need to do is expand using the algebraic identities. A plus B whole square, A minus B whole square. How will I do this? Very simple. A square plus B square. Remember, the square goes for both the term, rule of exponents. Plus 2 tan A tan B, or 2AB, plus again A square plus B square, and here it will be minus 2 tan A because minus 2AB. For those of you that need a quick revision on this, look at this. A square B square 2AB, A square B square minus 2AB. Acha, this is what I did. Now very simple, 2 tan A tan B minus 2 tan A tan B get cancelled. What is left now? Or we have to just play around with what is left. What is left is 1 plus tan square A tan square B plus tan square A plus, don't forget this plus, tan square B. Now look at your RHS. We need sec square A, sec square B. So take any 1 and 1 plus tan square A. We can write 1 plus tan square A as sec square A. And then from the remaining terms, take tan square B common. You will get 1 plus tan square A. Again write 1 plus tan square A as sec square A. So you will get sec square A tan square B. Now again take sec square A common. You will get 1 plus tan square B. And what is 1 plus tan square B, guys? 1 plus tan square B is nothing but sec square B. And this is nothing but your RHS. So it was a bunch of taking out common. Okay, let me just write the identity that we used. Sec square A is equal to 1 plus tan square A. This is the identity that has been come into effect. First, I took 1 plus tan square A as sec square A. Then I took tan square B common. Then 1 plus tan square A became sec square A. Then I took sec square A common and 1 plus tan square B became sec square B. Alright guys, so these were a few important sums related to exercise 21B. I hope you enjoyed this lecture. Post your doubts in the comments. Let me know how I can make my videos better. Any feedback, whatever you think that might help me, that might help other students, go ahead and tell me in the comments. Till then, I'll make some more videos for you guys, and we'll meet in the next class. Thanks for watching a lot. Bye bye.